How far is it from the tip of your index finger to the knuckle? How far is it from your living room to your kitchen? How far is it from your house to where you work or go to school? Chances are that you used different units of measurements to answer each one of these questions. Maybe you measured the distance on your finger in inches, the distance in your house in feet, and the distance from your house in miles. This is because using the same units of measurement for all these examples would at times give us impossibly large or impossibly small numbers. It is for this reason that we come up with special units of measurement to record distances in space. Consider that the average distance to our closest neighbor in space, the Moon, is almost 240,000 miles. That's a really long walk. This is a long enough distance to go around the Earth at the equator almost 10 times. Distances to other objects in space are much longer. The Sun is about 93 million miles from Earth on average. We all understand that this is an extraordinarily large number, but the human brain is limited in understanding just how big that is. So, we use the astronomical unit to describe the distance between the Earth and our Sun. The average distance of 93 million miles is equal to 1 AU, or 1 astronomical unit. Mercury and Venus are less than 1 astronomical unit because they are closer to the Sun than the Earth is, and the furthest known planet in our solar system, Neptune, no, not that one, yes, that one, is about 30 astronomical units away from the Sun. In fact, just a little bit over that. You might think that's the end of it. We can use astronomical units to report distances in space, and our numbers would be manageable. Unfortunately, this is not the case. While astronomical units are great for reporting distances within our solar system, the rest of space is so vast that the distance from the Earth to the Sun pales in comparison to other distances. The closest star to us is Proxima Centauri, and it is over 268,000 astronomical units away. Notice we are starting to get into those really large numbers again, so here we go with another unit of measurement. This time, it's the light year, and this describes the distance light travels in a vacuum in 1 year. In a vacuum, light travels at approximately 186,282 miles per second. So scale this up to a year, and you're dealing with a huge distance and a huge number. It's much easier to describe this distance as 1 light year. Despite the name, it's not a measurement of time. It is in fact a measurement of distance, and a really huge distance at that. The distance to Proxima Centauri is a much more manageable sounding 4.24 light years away from us. The last unit of measurement that we'll take a look at is the parsec. 1 parsec is equal to approximately 3.3 light years. At first glance, this might not seem like a very large multiplier and would not really differ much from using light years to report certain distances. But it is a useful unit of measurement for astronomers who are doing calculations based on certain telescopic observations. It's not really a unit that most students or amateur backyard astronomers would ever deal with. And that's it for measuring distances in space. I hope that this was easy to follow, and now you understand how and why we report different distances in space using these units. If you enjoyed this video, please hit like and subscribe, and share the video. It really helps us out. Have a great day, and see you next time.